Hey guys, welcome to my channel. Today we are going to discuss about Tensor, what is Tensor and how it's behave. So what is Tensor? Tensor is a mathematical object. Okay, it's a algebraic object that describe the multilinear relationships between different algebraic objects like scalar vectors, okay, in a same vector space. The object that a tensor is actually mapped that a vector to scalar or scalar to vector, even tensor to tensor. So in easy way we can say that a tensor and multidimensional array are quietly similar. Okay, so what is that? The tensor is a function, okay, that have its different mathematical operations, but the multidimensional array is a data structure that actually represent the tensor in a particular coordinate system. Okay, so here I am sharing example of tensor which you can see in any deep learning programming or code, that when you define a tensor it looks like that. So it's kind of represent a multidimensional array, but it's defined that it's a tensor object or tensor function. So this is the graphical representation, or you can say geometric representation of a different dimensional tensor and how it's look like. Okay, now for the practical operations, so we are really depend on PyTorch. Okay, so using PyTorch I need to import torch. Sorry. Fine, it is included. Now let me tell you one thing. If you are define a tensor in your GPU, then what happened if you do any kind of operations, like from if you want to move that or convert that tensor to a Numpy array and do some mathematical operations of that array, it's automatically going to reflect on the tensor. Okay, but it's not happening in CPU. Okay, so keep it in your mind that when you are using GPU, it's only share a single memory location. Okay, so now in my previous video I also show you that how you install a CUDA in your Linux system. Yeah, I am here using my Windows system. If you want I can share that also, that how you install the CUDA in your Windows. Okay. So before write down the tensor definition in PyTorch, I want to share the way how you use your GPU in PyTorch. Okay, so for that you need some condition, that if torch dot let's have CUDA is available. Okay, then you need to mention device equal to torch dot device CUDA. And whatever the operation you want to do, you can do here. Okay, else device equal to torch dot device CPU. So let's add some print statement to check the device after this. Okay, so what we have, available device is CUDA. Okay, so I am running in GPU. Okay, so let me define our first tensor. Okay, empty tensor. Okay, say the dimension is 3 cross 3. Okay, so a dot tens equal to torch dot this torch dot empty method is give you tensor which empty tensor having the dimension of 3 cross 3. Okay, so if I print, yeah, see, it's a 3-dimensional empty tensor. Now I want to show you some inner operation. Okay, it's called tensor inner operation. So what are the inner operation is actually available? If I want to add 1 in every element. Okay, so what I can do, adding a scalar in each element of a tensor. So I marked it, say a1. Okay, and I define a underscore tens dot add. With this underscore operation, it's defined that it's an inner operation. Okay, so by 1. Let me print also this. So it's actually I run it actually 2 times. So if again I run it, and see, now it's added 1. Okay, now say you can do any operations. Okay, if I want to do multiplication operation by a scalar or width of 5, then I a underscore 2 equal to a 5, and I am going to print a by 2 here. See, I am taking this a1 and do the mathematical multiplication operations here with by 5. Okay, so it's basically simple. Okay, so whatever the inner operation you want to do, you can easily do it. Okay, now I want to share you once tensor, means everything. When you define a tensor, that all the elements is become ones directly. Okay, like this. Okay, so for that you need to do tens underscore ones equal to torch dot, here is ones operation, and you need to define your tensor size. Okay, like 4 cross 4, and if we're going to print it, yeah, so it's by default it's defined a 4 cross 4 tensor with all the values of ones. Okay, similarly you can go with any dimensions. Okay, and all of that previous inner operations is also possible here. Okay, now there is another way to define a tensor, that is a random tensor. Okay, so it's important. So for that I define r10s and use torch rand function, and also defined a dimension. Say my dimension is here for 5 cross 5. Okay, going to print it here. See, it's a random tensor with 5 cross 5 dimensions, and it's have some datas also. Okay, now we are going to do some tensor to tensor operation, means involving two tensor, like adding between two tensor. So I am defining another random tensor, say rr10s, and with the same dimension. Okay, so I am just copying it and print what is in the rr10s. So see, it's another random tensor. Okay, now I am doing rr addition equal to rr tensor dot add and pass this r10s here and print this. Say it's perform additional operation. Okay, addition operation. Okay, between these two tensor rr10s and r10s. Similarly for multiplication, rr mul equal to box. Sorry, I have make a mistake here. Yeah, so this is your multiplication. Okay, so similarly this kind of operations you can do. Okay, so whenever you need to deal with a weight, you can do with inner operations, or if you want direct operations like multiplication, addition, subtraction, you can easily do that. Say we are dealing with some subtraction and we define dot sub with addition. Okay, see, it's the subtraction. Okay, so most of these are the basic operations you can easily do over the tensors, and that's it. That's the basic operations you can run over the tensor, and it's really important. So when we are going to look into that backward propagations or any other kind of mathematical operations that happened over the deep learning, we can easily understand that what is actually happens there, or what are the mathematical functions we need to call. Okay, now we are going to look into that numpy thing. Okay, so I am import numpy as np. Now if we directly want this array to convert in a numpy, so we can do as like this. Say I'm taking rr sub dot num array So now see, just rr.sub.num, it's converted this tensor to a numpy array and data type is float 32. If you want a different data type, you can also define there. Okay, now again I want to this in a tensor. Okay, so for that I am using num equal to torch dot is from numpy and pass this num array. Okay, and print this tens num, and see again it's converted to the tensor. Okay, so thank you for watching. Please like and subscribe my channel. I am trying to get every detail of deep learning or machine learning or any kind of technology related solutions or new kind of technology that I am working. I try to share with you. Okay, so please like and subscribe, and I really want to make a playlist from the beginning of a deep learning, so that's why it's a part of this video tutorials. Okay, so that you can get a better understanding from the beginning that how a deep learning is work. So we are going to step by step, and I really try to get at least one video in a week, so that you can continue get some learning material from my end and continue your journey in machine learning and deep learning. Thank you guys. Please like and subscribe and support me.